Okay, so a few more points about global climate change. We had said that for the last 135 years, temperatures at many locations around the world have been closely monitored. So we started having weathermen, right? So people were monitoring this, and on average, over the surface of the Earth, the Earth's average temperature has risen 0.8 degrees centigrade. And that was when this book came out. And this book came out a few years ago. What does that correspond to? It corresponds to 1.4 degrees Fahrenheit, so 1.5 degrees hotter. In addition to that, the 10 hottest years during this 135-year period of time have all occurred in the last 2 decades, and most of them in this current decade. There was a statement that I've written on the board, and it's from the International Panel on Climate Change from 2014, and it said that atmospheric concentrations of CO2, carbon dioxide, methane, CH4, and nitrogen oxides, nitrous oxide, NO2, are at their highest concentration in the last 800,000 years. That's how far back we can accurately monitor atmospheric gases. And their final caveat was that human activities are responsible. Now, so the question is, so we have a lot of circumstantial evidence to support the idea that the CO2 that is increasing in our atmosphere is from fossil fuel burning, coal and so forth. But how do we know this? And there's another evidence, another way scientists know it's from fossil fuels, has to do with an isotope of carbon-12, I think it is. Let me see. No, I'm sorry, carbon 14. So the radioisotope, it's in a radioactive form of carbon. It is, you can analyze its concentration in the atmosphere. It's only present in 1 out of every 10 to the 12th carbon atoms. It occurs in a low concentration. Now, what happens is and this is because that's the rate that it occurs in living creatures. But what happens is in the fossil fuels that have been underground for millions of years, it's basically zero. And so we have this small amount of radioactive carbon that's in all of us and in the atmosphere, in the CO2. And what they're finding is if you burn and add carbon that's been sequestered away for millions of years, they know that the carbon there is no carbon-14 there. So the carbon that is in the fossil fuels, it doesn't have this radioactive isotope because it decays and disappears over time, and this stuff has been hidden away for millions of years. So what they do is they said, okay, so if we're adding carbon dioxide from fossil fuel sources to the atmosphere, that means that the carbon-14 isotope concentration should drop as the CO2 level rises. So if we dilute out the carbon-14 with carbon that doesn't have any of that, that means the atmospheric carbon has less and less of this radioactive isotope. And that's what they see. And so this is another evidence suggesting that the CO2 increase in our atmosphere is from burning fossil fuel. Okay, so we talked about the ice cores and so forth. Okay. All right, I'm going to stop right here.